Okay, good morning, everyone. Or we can get started. I know it's already 9 o'clock, and that there is a quite good number of people registered for this workshop, but you only have few in this room. I'm pretty sure more will join later. We can get started. So maybe I can start by introducing the instructor. My name is Jinha Jung. I'm a faculty member at Purdue University School of Civil Engineering. And co-instructor is Qiusheng from University of Tennessee. So we are gonna do a team kind of led workshop today. So first half, I'm gonna take the lead, to talk about a new online platform that we've been working on called the Data to Science. In the second half, Dr. Wu will be covering second part where how we can expand this data to science using Python packages that he's been working on, GMap and LiftMap, and also coupling this with a drone data set with satellite images. So before we get started, and this workshop I meant to be interactive. We have full 4 hours that we can just work together this morning. So I'm hoping that you guys open up your laptop so that you can just follow along what I'm doing. Okay. So before I get started, to have some ice break event, I'd like to get to know who you are a little bit. So I'm assuming that this conference is an international plant phenotyping symposium, so you guys are working on plant phenotyping at least. So how many of you have worked with actual drone data set for your research or any type of activities? 2, 3, only 3? No one else has used drone imagery at all before? But probably the reason why you sign up with this workshop is because you are interested in this drone technology. So I think that's good. And how many of you actually used any type of remote sensing data for your the research program? It doesn't have to be drone. It can be satellite. It can be airborne imageries, anything. So how many of you used the remote sensing data for your research before? So I see more hands. Drone is in a part of drone, the remote sensing, so you can just claim that. Okay, so how many? Because this is the same question. How many of you actually created your own remote sensing data? I think probably anybody who's been working on just drone data set, you are creating your own data set instead of relying on federal agencies like NASA or European Space agencies, or paying big money to surveying firm to fly airplane for you, right? So, okay, we have the good number of hands coming up. So main idea of this new data to science platform that we are gonna cover in first half, first 2 hours, is comes from the idea that all those traditional remote sensing data set that is not collected by you, you have no control in terms of how this data is being collected, but how you're going to access this data set and etc. But this drone technology is kind of becoming very handy for all those agriculture scientists. Now you can get to generate your own data set. And it's been kind of quite exciting journey for last 5-7 years where all this hardware development in terms of drone. I remember the first time when DJI was introduced, DJI Phantom 1 and DJI Phantom 2. Those days, collecting drone data set was not that easy. Because you need to be an expert, you need to know what you're doing, all this kind of stuff. But right now, let's say that if you want to collect your own drone data set, it's pretty easy. What I'm saying easy is compared to what you have to do in, let's say 8 years ago. You need to do a lot of the manual work or the pre-planned work before you go out to the field. But right now, any DJI drone you buy from Best Buy, Walmart, they have all mapping capabilities, and it's just a matter of launch your app in your smartphone, just draw a boundary, saying that hey, how high I want to fly, what's the overlap, press a button, it just takes off, go collect the data, even do the landing for you, right? So this drone data set is kind of revolutionizing this agricultural research in a field where before you have to rely on those big players to collect the drone remote sensing data set. Now you are becoming a content creator. So all those the good development is great because now you have a freedom to create your own data set. But based on my observation, at least working in this area for the last 10 years, the area that is lacking the most is now you have a good hardware. Now you actually created your content or in a data set, but there is not a good platform to manage the data, share the data, and visualize the data. And most of those in agriculture program, at least that I know, the way how this agriculture program works is that, hey, I collected data, I'm going to copy this the data set into my external hard drive, and process in my laptop workstation, store everything in hard drive, then I do all the processing locally. But if you look at all those recent development in AI, the deep learning, machine learning, the area that this area is led by those big tech companies like Google, Facebook, and Amazon, all this kind of stuff. They have one thing in common, which is they are the one who has access to the data. Right? Not only the data they create, but most of the data is actually uploaded by all the others. So the main idea of this platform that we're going to look into for the next 2 hours is that I want to give you that freedom where now you collected or created your own geospatial data. Then how you can actually manage this data set very, very easily, and how you can actually share this data easily, and how can make this data set you created, beautiful data set, easily accessible from any computing platform that you might be interested in. Okay, so I think I already spent good about the 7-8 minutes to talk about why we worked on this data to science platform, and I'd like to acknowledge the funding source to do this, and Act2PI, which is a USDA program. Agriculture Genome to Phenome Initiative is part of the funding to make this happen, and another big chunk of funding coming from the school that I'm affiliated with, Purdue University School of Agriculture, is another big the funding source to make this happen. So what I want to do is that this is actually a documentation site. We regularly update. So if you just type that in, the URL here is, let me just show you here, https docs.gds.org/data to science user manual. And basically what we're going to do is then we're going to be following this manual throughout. Okay? So everybody ready to get started? You have your laptop ready? Everybody's connected to the network. There isn't a Wi-Fi. It is NU guest Wi-Fi. I believe, let me just open up this code here. I believe password, ID is October, and password is Innovate 2024 exclamation. So everybody get connected online? Everybody's online already?
Is that the name of the network is guest?
The network is NU guest. Yeah. Like I mentioned earlier, I want this to be interactive. If I go through what I want to do, I can finish in 30 minutes. But the reason why I'm spending for 2 hours is that I want you to be part of it. So after this workshop, you go back to work and we can start to use this platform for your program. I'll make sure everybody's online so that we can follow with me. Everybody's online? Anybody having any issues with getting online? Or if you're not online, you cannot follow through at all.
When you connect to the network, it just doesn't show anything to provide.
Yeah, if you just try to go on your website, then it will ask you any password. So once you just connect it doesn't ask you anything, but open up a browser, go to Google or whatever website that you never visited, because I think if you go to Google, they just show you a local cache. So go to any place that you have not visited before. Then that's when they're going to ask you what is the ID and password. So what I did is, one good way of doing it is that once you connect it, then if you go to d2s.org, this is under construction website that we're working on. You're going to have official website. I'm assuming that you never visited this website before. Then you will see it'll ask you to type in ID and password, and the ID and password that you can type in is going to be this one. Let me just make sure this matches with October Innovate 2024 exclamation. Yep, that is correct. So anybody who is online, can you give me a thumbs up so that I know you're ready? So you're good, you're good. In the back, you online?
My computer's in my office, but
Okay. The other thing is I'm recording this session, so we will make this recorded version available later after Dr. Wu's channel and my YouTube channel as well. So we'll have a record. So in the back, are you okay? Get online?
Yes, but I'm still what website as well.
So you try to go to d2s.org, and it should ask your ID and password.
Okay.
Because essentially, any website that you visit, they said, hey, your IP or in a MAC address is not registered. Then they'll ask you ID and password and type in October 2024. Two in the back. Are you online?
Yes.
You online?
Yeah.
Good. I will give just one more minute so that the one gentleman in the back can be online. Once you, for those who are online, then I want you to go to this website. So let me copy and paste this into the window here. So just type in this in https://docs.gdsl.org/data to science user manual. And then you will see this website. Let me just make this one. And like I mentioned, this is a living document. Every time we have an update, this document will be updated accordingly as well. So please, bookmark this page so that if there is any features that you don't know what it is, this is going to be a good place to come back and check and how any of the things that I demonstrate is going to work in the future. So everybody on this website, so if you click, let me just give it. I know, typing sometimes kind of easy. I wish I made some kind of, barcode so you can scan, but it works for your smartphone, but it may not work for your laptop. So I'll just give one more minute.
This is different from the course material which you sent.
Yeah, the course.
The email I sent is the second part.
Yeah, second half.
Oh, this because I saw part 1, part 2.
Yeah, that one, part 2 is from mine. Here's part 0.
We're going to do a lot of coding in second half. So.
Yeah, well, we put all the links together later in the video description.
Yep. So everybody on this website, you good? Good to go? So I'm gonna make this page full screen, and this is the team, at least from Purdue side, who is involved in this. Myself, this Ben Hancock is the full-time programmer working on this project. Min Young is the postdoc working on this project. Benny is Egg IT from Purdue, and Dr. Cheryl and Jonah is from School of Art, because we do a lot of user interface, user experience in design, and Dr. Wang and Louis is from School of Agriculture working on field data integration. So these are the people who is involved in this project. Then I'm going to click getting started, and what I want you to do here is go to download sample data. So I want you to download this sample data to your laptop, because we are going to be using this in an example data set to be uploaded to your own account later. Okay? So what I want to do is I want you to click this file so that it's going to be downloaded to your the computer. So field boundary file and sample data. This is a few hundred megabytes, so it'll take some time. So I want you to click this. And there is additional multi-temporal sample files located here. So I want you to download these 3 files. Okay. So click those 3, let it download. Then it will just go to another point, and hoping that next time when we need to actually use this sample data set, this download process is going to be done. So everybody initiated the download data part? You good? Okay, next one is sign up. So in order for you to to create an account on this data to science platform, there is a website called HTTPS PS2. PS2 doesn't mean PlayStation 2, as you imagine. This is a Plain Science 2.0 initiative, which is the funding source from Purdue side. And the PS2.D2S, D2S stands for Data to Science, .org. So if you just click this website, and it will look something like this. So you're going to see a screen like this. And if you already have an account, you can click sign in. If you don't, and click sign up, and put your name and email and the password. It says over here, your password must use at least 12 characters. We don't have a requirement to use any special character or anything, but I think one requirement is that you cannot use three characters in a row at the same time. So as long as you meet the requirement, your password will be good. And click create an account. Once you create an account, then you will receive an email saying that, hey, you need to confirm your email address. Then as an admin, I'm going to approve your account. Then you're good to go. So what I want you to do is everybody go ahead and create an account. The reason why I'm doing this is because later I'm going to create a team, and I'm going to make those teams have an access to some of the example projects that we're going to use as a demonstration. So I want everybody go ahead and create an account. Then I will approve your account as soon as possible. So Who has already created your account already? So 2, 3. So rest of you already have your account created? Okay. So let me see if there is any account I'm going to approve. Probably, I think this is kind of becoming a speed battle between me and my programmer Ben, because every time Ben beats me. Yeah, I beat him this time because it's already approved. Let me just go ahead and click all your name. Make sure your account is approved. I'm gonna approve your account. I don't see any other. So Richard, who is Richard? Okay, I will add you. And Valerio, probably not in this room. Ragupathy, okay, sorry. If I put Afolabi, not you? Okay. Approve your account there. And next one is, okay. Next one is ENHE. Okay, got it. So everybody has an account. You also need to confirm your email, because your email address will be used as a way to recover your password if you forget it. So I cannot change even your password. So if you forget your password, then the way that it's going to work here is come back to this website and click login. And if you don't remember your password, forgot password link, then they will send you the password reset email to your email. Then click the link, then you should be able to reset your password. So confirm your email. If you don't see the confirmation email in your inbox, chances are that it might be in the spam folder. So make sure you confirm your email, then using the password that you just created, then click login, then you should be able to see this screen. Right now, I see a lot of projects because those are the list of projects that I have access to. Probably, if this is the first time you log in, then you don't see anything because you don't have any access to any project. So I just want you to make sure everybody is logged in. So can you give me a thumbs up if you already logged in? Good, good. Second row from the back. I know that you came too late, so probably, yeah.
It's okay, we'll
Yeah.
just watch.
Okay,
Not yet.
okay.
I think it says my account requires email confirmation.
Yeah, you need to check your email,
I didn't get it.
check your spam folder.
Directly.
Nothing?
Nothing.
It may just take a little bit while. Yeah,
It just started.
got it. You already logged in? Yeah, you logged in? You logged in? Okay. So once you log in, you're going to see 4 menus at the top, and your the profile here. I mean your the name, and I just added my the photos. So I see my photos. But if you haven't uploaded your photos, then you're going to see first and last name the upper letter. So what I want you to do, okay, let me just give him a little bit more seconds so that he can confirm his email login. So we can just move everybody together. And I don't want to steal thunder from Dr. Wu, but we're going to have a lot of exciting examples, using the drone data set that we have. I think we have field level, the analysis plus some of the segmentation. Probably you guys heard of SEM, segment entity model. So I think Dr. Wu is also managing Python package called SEMGL. So we're going to be talking about how we can just do segmentation using the drone data set on this platform later. So were you able to log in? Okay, good. So what I want you to do here is click your name and go to your profile. So you're going to see your name, And the one thing that I want to do, of course, you can change your password below. But what you're going to see here is that probably this is how you're going to see look like. Because by default, API key is not created. But later we're going to demonstrate how you can stream this data from data to science to QGIS. And QGIS, the authentication method that we use in a JW token, the Java web token or something. But the QGIS doesn't know JWT, so they don't know how to authenticate. So they do the authentication based on the API key. So what I want you to do here is click this in a request API key. And this key is going to be your kind of ID. So anybody has an access to this in the API key can log in as you and access all your data sets. So please make sure you don't expose this in API key to anybody, because this is almost like giving keys to your house to anybody so that they can just log in and access all your data set. Of course, I'm gonna, if you just for somehow say that, hey, this might have been compromised, then all you need to do is revoke it and generate it again, and the new random API key will be generated. You don't need to memorize it or anything. You don't need to show anything. But later when you talk about QGIS, the login, and they will grab this API key and this API key information to this server so that they know who you are later. But please make sure click this generate API key so that you have your own API key is being generated. Is everybody okay so far? All your API key has been generated? Okay, good. So next is contact us. So probably I don't need to explain what it is. If you have any problem or if you have any suggestion, click this link and give a subject give a message send. Then both me and my program will receive an email and we'll respond accordingly. Okay. Next page is my team. This is where you can create your own team. So let's say that like I mentioned earlier, this platform is all about how to share your data within a large group of people. And for that, we created a feature called My Team, so you can create as many teams as you want. And I already have many teams listed already over here. Probably for you, you will see nothing because you haven't created any team. And what I want to do is that I'm going to create a new team over here. Then I'm going to say that IPPN 2024 workshop. This is a team for IPPN 2024 workshop. And from here, I can just add as many members as possible so that later I can assign certain project to a team, then anybody who belongs to this team will have an access to this, the project, automatically. So what I want to do is, go around the room. Who already has an account, I'm going to add you to the team. So let's just start with you. What's your name?
It's Henry, Henry.
Okay, Henry. I'm going to search for it. Henry Ruiz. Okay, I'm going to add you. Next. E-H-E. So this is you. I'm going to add you to the team. Next. AFO. I think it is. Yeah. Next. You already have an account?
No.
Bro, you can join late. So your name? S-H. Masahiro Okada. Okay. Next. I think you're coming late. So, yeah, your name?
R-A-G-U.
R-A-G-U. And I think this is you.
Yes.
And gentleman in the back.
Richard Dickman.
Okay. And last.
Rakesh, R-A-K-E-S-H.
David. So I added you to this, create a team, and let's say that I like to add to project. I have too many, so I have almost 300 projects. So I think you can just search by it, but I think a workshop here. think alphabetical order, maybe not. So I will just show you, how to assign to this, to a team, later. So I'm done with the, project, the team creation. So I'm going to click done. Then now I see IPPN workshop has, this many members, already. So this is how you manage your team. And once you create a team, you can add more members. For example, I like to, add, Qiusheng to this member. He already has an account. I click, add to him. So, you can add more members, after you create, members as well. If you like to remove members from the, team, you can just click remove. Then remove the, that specific member from the team as well. Okay. So this is how you manage a team. Next page is where you can actually manage your project. So I'm going to go through how you can actually create a project later, but at least for you to get started, and what I want to do is that I create two, the example project created for this workshop, and I'm going to assign those two projects to IPPN workshop team that I just created. So I will search for workshop example over here, and once you click it, we are going to go through this in the process later. But if you see team was assigned to nothing, I can just change it. I want to assign to IPPN 2024 workshop and click apply. Now everybody who was added to this team, if you refresh your homepage, then you should see the project that I just added you as a member. Good. I'm gonna add one more the project. So workshop over here. I believe this is another one that Dr. Wu will use as an example later. So I'm gonna assign this to this team as well. Then now coming back here, you should see two projects. So now you see that how easy it is to share this data. It's just a matter of assign this project to specific team members, then you're just good to go. And another way of doing it here is, let me just go to this workshop project. Let's say this is someone. This is the menu where you are assigning this project to a specific team. But let's say that if you like to invite another member who is not a part of this team, then how can you do this? Click this and manage access button. Then these are everybody who has an access to. Then I can search for additional member. For example, if I just click Ben, I have a lot of Ben over here, but click this, the Ben Hancock as selected, and this specific person will have an access to this project on top of the team that I assigned to earlier. Okay. Okay. Yep.
Can you assign more than one team to a project? Or just individual?
So the way how it works is that whenever you assign this project to a team, and we have for loop in the running background so that all the member in the team will be added to this automatically. So if you want to assign to more than one team, assign a team first, assign to another team, and both of the team will have an access to this project. Okay, so everybody can see two projects in your home screen. We're going to come back to this in a point where how we can actually visualize this data set.
If you need help or sign up, I can help you.
Yeah.
Yes, I can help you.
Oh, signing up now, okay. Then he needs to approve.
I'm just connected.
Okay.
Yeah, okay.
I see Brandy. I'm going to approve you. I think once you confirm your email, you should be able to log in.
Okay, so you do that.
Juan.
What's your user? Can you add him to the pro?
Yeah, I will.
What's your ID?
But please make sure you are logged in.
Yeah, he is already logged in.
Okay, so.
What's your username? You know, yeah,
So I'm gonna go IPPN. What's your name?
Vincenzo.
Is that?
Vincenzo.
What? Can you spell?
V-I-N-C-E.
V-I-A.
N-Z.
V.
No, V-E.
V-E.
I. V-I.
V-I-N.
VIN. You just search VIN.
Okay, this is okay.
Uh-huh.
Okay.
Okay. Edit. Then
And what is your name, sir? Juan.
you can refresh your.
Well, have you confirmed your email yet?
We have here.
This is another one that I know.
Oh,
That I know he's not here.
Yeah, you can create one. You can create one. It's free. Yeah, it's free. No, you don't need to pay. It's free. You show later how to sign up.
So you just saw that I added Vincenzo to the team. I never added him, but if you just go to the workshop, sorry. Over here, click Manage Access. He's been added to this project automatically because even though I added him later.
You only saw the name here, but you need to confirm it.
You need to confirm your email. Otherwise, registration is not complete.
It might be a little bit late. Maybe wait a minute or two.
Qiusheng, can you help him? So that I think we're quite a the delay, so I'm going to move forward so he should be able to help you. Then once your account is registered, I will add you to the team. So what I want to do next here is I like to create a new project. So remember we downloaded 3 data set earlier. Let me just go to the download folder here. These are the 3 files that I downloaded. Mac, they just uncompress this automatically. If you're a Windows user, you should have a zip file. Don't unzip plot boundary because we're going to use that compressed zip file to create a project later. But for these other 2, sample data for uploading and the additional sample data, that zip file, you can just uncompress it so that you have this as a separate file. But I'm going to do copy this one to another location here. I'm going to create a folder called IPPS 24 workshop. And I'm going to move this data set back to this directory so that we can work out of this in a folder. And I'm going to actually compress this back again. So if you have downloaded the original plot boundary.zip file, you don't need to uncompress it. Okay. So everybody download this data set. Okay. I think you should be able to download this by right now. Okay. So what I'm going to do here is that I'm going to demonstrate how you can create your own project. So the way how this system is configured is that you can create a project. Project becomes I'm going to just explain as an agriculture the kind of perspective because this is an IPPM meeting. Project is going to be one geographic location where you are conducting your own experiment. It can be the variety trial. It can be the different nitrogen trial and etc. But you just have some the crop planted in the field. You just do the experiment for the whole year within just one geographic location. That defines your project. Okay. Inside the project, since this is a drone data set, designed to have it in mind that you're going to manage your own data set. Inside the project, you can have a multiple flight created. So you have the flight early in the season, another flight in the middle, another flight late in the season over the same area. And inside the flight, you can upload your raw data. And you can also upload your raw data, the data product, which is data product generated from the raw data as well. So that's going to be a process that I'm going to go through. So let's say I'm going to create a new project. So right now, everybody who has an account and added to the team, you're going to see 2 cards here, workshop for the farmer's field and another one for the citrus orchard. And we're going to create a new project using the sample data set we created. So in order for you to do that, click Create button. Is your account ready? Okay.
He can add you to the project.
Okay, so give me a second. I'm going to go to the IPPN workshop. I'm going to search for one. Now, this is you, right? I selected. Now you should have an access to. Okay, now click create. This is the page where you can actually create a project. So like I mentioned earlier, in order to create a project, you need to define where your project boundaries are. So you can just do this by zooming in, and let's say this is the field that I'm working on. There is the button here where you can just actually click the boundary manually like this. This is one way of doing it. But let's say that I don't like this. I'm going to just delete this. And there is another button here. It says the search button. Let's say that this is developed from Purdue. So this map is by default zoom into West Lafayette, Indiana. But in some cases, what if I have a project in Africa or Denver, Colorado? Zooming out and zooming back in is taking a lot of time. So you can just search by Denver, for example. Then they will give you all these geocoding options. Like this is the Denver, Colorado here. They're going to zoom into this whatever address they typed in automatically. I believe you can type in any keyword. You can type in address. You can type in longitude, longitude, whatever keyword you just type in. That will actually let you zoom into the area. Then from here you can just draw the boundary using this the pointer tool over there. Another way of defining your project boundary is let's say you already have your shapefile as a polygon of the boundary, and you can upload the shapefile as a one single G file as to here. Then they will create the boundary automatically. So what I'm going to do is we already have the project boundary.g file downloaded. I'm going to click this and upload shapefile. Then this browse file, go to the directory where you are created, download your data set to, which is in IPPS 2024 workshop and project boundary.zip. Click upload, and it says that hey, it's ready to upload the file. Click upload file, then they will. Oops. Sorry, let me just do this again. We just upload it here. Oops. I think this is a danger of doing a live demonstration. Probably we are doing. Another thing I forgot to mention is that this is a very early project. First version was released in February, earlier. So we are doing a lot of updates, so sometimes some of the features may not work. So we will get it fixed for sure. Is everybody experiencing the same?
No, I could see the field.
You can see the field?
Yes.
Okay. Probably then that the way I created this in a boundary file is a problem. So let me just try to move this one back here, upload. Let me just try to upload one more time. This is the file that has been, okay. Probably the way how we created this, the compressed file from Mac was, caused a problem, but I just used the, download the zip file. It works. So when you have a multiple shape file, I think I know what it is, because I compressed the folder. I should have, the cycle auto shape file and that, compress that as in a zip file. Because when you unzip it in the server side, they compress in the folder. That's where they kind of confused. Anyway, so they just show the boundary automatically over here. Okay. Then let's give a title of the project. So I'm gonna, in order to differentiate, my project with with yours. Another thing is that once you create a project, unless you make this project available to others, even I as an admin, I cannot see your data. So there is a guarantee that your data is going to be yours until you make it available to others. So I'm going to make it Jinha's IPPS 2024 workshop example project test. Just give a description. And let's say this is your experiment that has a planting date. You can set that starting date to be a planting date and end date to be your harvest date, for example. But this is an optional. You don't have to set it. And at the bottom here, you can assign this to a team. So let's say, if you already created a team, you want to make this project available to all those team members automatically, then you can assign to, for example, IPPS 2024 workshop. Then once I create a project, and everybody in this the team will have an access to this project automatically. But for now, I'm not going to assign to any team because this is meant to be your own project for this demonstration. So once you have this, then you can create a project here. Now you're going to see 3 cards. I have a lot, so I don't see it. But if I search by my name here, I'm going to see this project that I just created. Okay. Once you click this, and you see that the information you entered during your project creation is available over here. You can click Start of the project. By editing, you can add a date over here. I can cancel it out. You can assign an end of project. You can assign to the team. You can update the project boundary if you want, which I'm not going to do. So this is how you can create a project. So everybody was able to create a project. I'm sorry whoever joined late. I wish I can go back and help you, but
I can help them.
Yeah. But we already have quite good amount of things. It's going to be hard to for them to catch up. The other thing is that we are recording this for those who are joining this late. We're going to make this video available so that you guys can follow up later after this workshop. So whoever started with me from the beginning, everybody can create your own project. Give me a thumbs up if you can. Good? Okay. Now, once you create this project, like I said earlier, you can manage access and add a new member by searching name. You can deactivate project. So if you want to delete this project, we have another layer of protection here. You don't accidentally delete this project, and they just said that. Yeah. So you can just click yes, deactivate. It will delete the project from the server. But right now, I'm not going to do it. Okay, like I mentioned earlier, you can now create a project. Now you can add a flight into this project. So going back to the documentation page, over here, my team, workspace, create a project. Oh, download sample data. And these are the flight information that you guys downloaded. So I believe first data set is July 25th, okay? And the multi-temporal one that you download is June 4th and June 23rd. So let me just go back. Sample data for uploading is July 25th, okay? And the additional sample data you have June 4th and June 23rd. So we need to create 3 projects, 3 flights, okay? So we have a June 4th, June 23rd, and July 25th. So, and we're going to use this information. So going back to, and these are the specification of the sensors that is used to generate the data. Oh, another thing that I want to demonstrate is we do have a capability to process raw data on the cloud, but we are using edges of Metashape in the backend because of the license issues. We cannot open up to everybody. So the feature that I'm going to demonstrate right now is only Purdue folks. I cannot open up to everybody because I'm going to get sued from Edgesoft by doing so. But I just want to let you know that processing on the cloud is actually possible. So let me go to the Phenotyping demo here. I'm going to delete all this data so that I can demonstrate you can actually process data on the cloud. And you can also upload the raw data. You just have all those drone images that we collected, compress in all the folders as a single zip file, and click upload raw data, upload it over here. Then that is raw.zip is actually raw data you just uploaded. And for those of you who has access to this in a backend, you see this process button shows up. And once you click this, and they give you an option whether this is RGB or multispectral, what kind of processing option you want to use, low, medium, high for the online photos, and low, medium, high for point cloud. And I'm going to just set the default value over here, click Submit Job. And what is happening is that those raw data set is being pushed to GPU cluster at Purdue, and that they're going to actually start to process the data. It sees that at the pending, it turned into 0% right now. they actually finish pushing this data set to GPU cluster. You see now it's 2%. They're going to keep crunching those numbers, and once this reaches 100%, all those data product will become available over here as well. Okay, so I'm going to come back to this the project later to demonstrate that we can actually process data on the cloud as well. But let me go back to this one here. Now we're going to add a new flight. So I'm going to click this new flight over here. Going back to this one here, let's create the first one. This is acquired in June 4th, and this is right after planting. So I'm going to give a name here, early season, and this is acquired on June 4th, 2022. It was flown at 40-meter altitude and 85, M300, and RGB. So I'm going to go back here. 85% side overlap, 85% forward overlap. Sensor use was in RGB. I have a M300, and I'm going to just, on the person who have an access to this project, we show up here. Right now, I'm the only member who has an access to, so I'm just seeing it. So I'm going to assign me as the pilot. I'm going to click the create a flight. Then you see that early season flight has been created. Let me just add 2. So I'm going to say mid-season flight. This was June, when was it? 23. So it's June 23, 2022. Flown at 40-meter, 85%, and RGB, I believe. Let me just go back here. We have a RGB, and same thing here. I'm going to just upload the RGB only, so that we can just demonstrate. But you should be able to create another flight with a LiDAR, another flight with a multispectral. You can add them later. But I'm going to just click create. And last one, late season, was July 25th, 2022, 40-meter altitude, 85% overlap, 85, RGB M300, create. And let me just add one more, because we do have a multispectral for this one here. So this is 40, 85, 85 in Phenom 4. So let me just go back. Okay, late season multispectral, July 25, 2022, 40-meter, 85, 85. Now the sensor is multispectral. Phenom 4 was series created. Let me just do one more. Late season LiDAR, 25, 2022. I believe this is also 40. LiDAR doesn't have any meaningful overlap, but I'm going to just put any information over there. This is in a LiDAR, M300. So I created 5 flights, okay? 1 early season, 1 mid-season, 3 for late season, 1 for RGB, 1 for multispectral, 1 for the line over there. So let's start to upload the data. So once you create a flight, this card will be created. And there is a couple of options here. Whenever we upload the data product, this thumbnail will be updated with the data product uploaded. Number 0 means that we don't have any data product uploaded yet. This button here is that, let's say you accidentally uploaded this flight to wrong project. Click this one, then you have option to move it to another project. Okay. This in a trash can. Yep.
Can you add extra metadata to your, say you have more metadata that you want to add, can you add extra fields?
As of now, no. But those are the some of the the suggestions we are happy to listen, because I've been also talking to some other communities. I believe that there is a metadata standard from, especially for this plant phenotyping in a MyAPI. So they have very well-defined metadata standard. So potentially that can be actually incorporated into this platform so that we can have a more flexible metadata entry. But right now we don't have that option at this moment. Okay. And this trash can is to delete the the flight, And edit flight is the one where we can go in, we're updating whatever information to entered right now. And manage data is the place where you can actually, manage your data. So I already showed you how to upload the raw data. Just click, raw data tab, upload raw data, compress everything, single G file, upload it over here. And if you don't have this and access to the backend, you can still use this as the place where you can save your raw data, so that you can download it to another machine and do other data processing. Yep.
Can a user delete the project it didn't create?
Sorry?
Can a user delete the project it didn't create?
For example, I added you to workshop example, and if I just click manage access, and I'm the owner, you are viewer. So if you come to this in a project, you're not going to see deactivate project button because you're not the owner.
So the user is not offered the option to opt out of the project willingly.
So only owner can delete it. And the manager cannot add new people. Manager can do more processing, which I'm going to demonstrate later, generating additional data product based on data product you upload. And I think there are a couple more things that you can do, but as a viewer, as the name suggests, you just mainly have read access to this project. You cannot modify it. Okay. Okay, go back to this project that we are working on. Now I choose June 4th RGB and click the data product. Now you see at the bottom it says upload data product. So you just click this. Now you have an option to upload a different data product, DSM, point cloud, also. If you click other, you can just name whatever you want to call it. Let's say you just generate the excessive greenness index from automosaic images. You just type EXG, upload this TIFF file. You can just do it. But let's start from this DSM. So click DSM. You can drag and drop into this box or browse file. This is additional sample data, June 4th in the DSM RGB. So I just click upload. It says 33 megabyte. Just click upload one file. Then it's going to upload this data to the server. Please stay with me because over the public Wi-Fi with I'm not sure how many people is trying to upload right now. We are not the only workshop that is going on, so this may be slow. But now this data set upload is done. Click done, then you see this data product has been uploaded. So what is happening behind is that we are using something called a cloud optimized data format. So every time you upload this in a regular TIFF file, on the back end, we convert this into cloud optimized GeoTIFF. So then now you can stream this data to whatever computing platform without downloading it. So there is an additional step that's happening in the back. So let's upload the DSM. Then I'm going to upload the auto from here, auto RGB, and click upload one file. This upload is pretty good, 132 megabyte, and click done. And what it's doing is that they're actually converting into cloud optimized and creating a thumbnail. It makes becomes available here. And do we have anything else? We do have one LiDAR. But even though this is collected from LiDAR, point cloud. So I'm going to say that I'm going to upload a point cloud. So click this in a browse file, June 4th in the point cloud LiDAR, and click upload. This is being uploaded. Click here. So now uploaded the DSM, orthomosaic images in a point cloud. And what I want to do is that I want to do for rest of the other. So this is June 23rd. Coming back here, DSM, click upload. Done. Click also, ortho RGB. Done. Let me go to July 25th. I believe we have a LiDAR for this and sample data for uploading here. June 25th in a LiDAR, click upload. Wow, this network speed is quite good. I'm impressed. And this is LiDAR multispectral. I'm gonna upload the ortho here for the multispectral. Upload. Done. And RGB, I'm gonna upload ortho as well. Go to RGB, click upload. Okay. I know I went through very, very quick, but at least you guys, you don't need to upload everything, but you know what? I'm gonna assign this project to everybody so that you don't need to upload everything with me, but you can actually follow with me. So I'm gonna assign to this an IPPN. Then you guys all should have an access to this one as a reviewer. Okay. So if you just come back to this in a workspace, then you should able to see this in this one that I just uploaded. Everybody can see this? You already have an account?
Yeah.
Okay. So what's your name?
Raul. R-A.
Sorry?
R.
R.
A. U. L.
This is not your. Ah.
Just write in A-R-I.
So A.
R-A, because there's an accent in how it's
Yes.
That's where you can find it.
Do you see your name?
Just R-A.
R-A.
R A.
Yes. Yes.
Which one? This one?
This one. Thank you.
So now you should have access to the project that I was sharing. So let's say that you kind of see how you can create a project, create a flight, upload the data product, etc. And let me go back to this in a peanut demo that I was talking about. See now, remember it was empty. I click this in the process data. Now this 3 data product is available over here as well. Okay. So I kind of, showcase that you can actually do the data processing on the cloud. But coming back here, this workspace is mainly for managing workspace. I'm going to come back to this in homepage where you can actually visualize your data. So let's search for the project that I just shared with you. And the other way of doing it is you can just click this number. Every time you click, they're going to zoom into this project, through boundary. If you know the location, you can zoom in and out. And let's say I'm going to go to here, then choose this specific project. By clicking this marker, you can get into the project. But let's say I want to open this project, you can simply click this card. Then now you're going to zoom into the project boundary, and you see all those projects available on the left. Okay. So starting from June 4th, you see this card. There is the text says a 3 data product. If you click this 3 data product, then all the data product that was in the flight is shows up over here. So if you just click orthomosaics, then you're gonna see the actual orthomosaic images that you uploaded displayed over here. What we are doing here is that, like I mentioned earlier, all the rest of the data set is converted into cloud optimized geotip so that we can stream it. We have a dynamic tiler running back in the back end where you can do different rendering. So, for example, this is 3 band images. Red is in a band 1, green is band 2, blue is in a band 3. Let me just show you another example. So let's say this is a multispectral. If I click this, you see it in an RGB representation. This is a multispectral way, but the red, green, blue, red edge, and near infrared. Okay, and you all know that if you want to do color, what is that? False color composite using near infrared, you can assign near infrared as in a band 1 in a red band, and red as in a green, green as a blue over there. Click apply changes, then you see the usual kind of color representation that you are familiar with the near infrared images. And we are not pre-rendering these images. You are just doing dynamic rendering of this combination that you're looking at. So coming back to this all the season, you have orthomosaic images so that you can see actual, right after planting images shows up. See the in high resolution, the being, landed, on the fly. You can also visualize in a DSM. So let me just zoom out a little bit. And if you click this in a DSM, for the single band, you can assign different color map. So coming down here, I want to use a jet color map. Then they're going to be rendering these images with a different color. I like to use a prism. This is probably not the good one to use at the GIS, Earth. You see that actual, the color map is updated over here with the actual value. You can also, change this in a min-max value by click user define. Now this value becomes, editable, or you can just do min plus minus standard deviation as well. Okay. And whenever you have a point cloud, if you just click this in a point cloud, and we also convert all the point cloud into cloud optimized point cloud format as well. So we can actually stream this 3D point cloud into this in a browser. This is right at planting, so you may see nothing over there. But if you go to late season LiDAR, click point cloud over here, you'll start to see there is an actual more crop shown up over here. So you can do 3D point cloud visualization as well. Okay, another thing that you can do, I'm using Safari, so this is kind of not rendered correctly, but if you're using Chrome, you're going to see better. But there is a button here that says a single layer view, but there is another button that says a comparison view. So once you activate this, I can just exit out over here. You can choose different flight. So I like to visualize earlier flight and orthomosaic images. Then now I can just zoom in, and you can just move your slide bar so that you can see how it looks like an earlier decision, how it looks like in a later decision. So you can do comparison of different data product in this way. And other one here is that we have this in a measurement tool in every map. So you just click this in a plus button, and you can actually do a measurement. So what is the length between these, the plot here? This is 8 feet. I'm sorry about the European, the audience. In the United States, everything is in not metric. So we have to, rely on this US customer unit. So it's given in feet, but you know how to convert it into meters, right? So you can just do this kind of measurement. So now you can just go to different data product, and you can just come back to this original point, finish measurement here. Let me just refresh this one so that I can search for my project here. And you can just visualize different data product like this. You can do the measurement, etc. And one of the very handy features is that, like I mentioned earlier, not only you can access this data very easily, sharing this data set with others becomes extremely easy as well. So let me give you an example. This is the data set that I demonstrated is only a few hundred megabytes, right? But you know that this drone data set can generate large files. And what I'm going to do is that I'm going to be actually showing you one of the largest drone flight that I have so far. This is about 2,000 acre in a field that I covered in 48 hours in the middle of nowhere in Amazon rainforest. And let me just show you actually that data. So I go to the Tipitini here. And if I just show you this in multispectral images, this is in Ecuador. This is in the middle of nowhere. This is about 2,000 acre. The orthomosaic file itself is about 170 gigabyte in size. So imagine that if you want to share this with others, what you're going to do is that you first need to have some kind of server where you can upload it so that others can download it. The other party should download this data set to their machine, which will take forever. Then they need to have some software, which they know how to open it, right? But the good thing about here is that at the bottom, there is a button called share. If you click this button, by default, it is restricted, meaning that only you and whoever you've given access to this specific project can see this data set, unless you authenticate yourself. But there is another button at the bottom that says anyone. So once you open this up, now I'm going to copy this in a URL. I wish I can. Let me just do this. bit.ly. Let me just copy. Let me log in. I believe I do have an account here. Click login. Then I'm going to create something new. Link. TBS. I'm going to say that the IPP and IPPS 2024 workshop example, TBS example. I'm going to click create. So if you just copy this URL, to open up your browser.
We also get the QR code so they can scan.
Oh, okay. Where is the QR code?
You close it and then.
Okay, I'm going to copy the link, or I can.
Close it and then create QR code.
QR code here. If you're using your smartphone, you can scan this. Then your smartphone is not logged into account, right? But you should be able to see exactly the same screen that I'm showing over here. And you should
need to zoom in a little bit so they can see the details.
Yeah.
Oh, no, I'm saying the imagery. Otherwise, it's
Yeah.
not.
So let me just zoom in. Let me go back to the QR code here. If you scan it, open up in your browser. Yeah, get close. No problem. Everybody can see the map?
Yes.
Yeah. Try to zoom in. Again, this is 170 gigabyte orthomosaic images. Now, you can actually see this data set without downloading it. This is the beauty of cloud optimized data format. You are not downloading the data, you are streaming data right now. Like all those the YouTube video, you never download your video, you stream so that you can skip to the middle, you can watch from the middle. You never download the whole video. Same thing is happening on this data science here. You just share this link, you are not downloading whole 170 gigabyte. You have a now capability to stream only portion they're looking at the resolution that is needed. That's the reason why you can access this data set so easily. Yeah.
So once I hit the QR code, if you've made changes on the side there, will I be able to see those changes?
No. Because what is happening is that the URL already has an embedding of this in a color rendering. So they said, hey, band, use the band 5 for rand, band 2 for.
I can't see those settings.
You need to have an account. So if you if you have access to a project, you can change the settings and then you share, and then other people will see the same thing. It's kind of like already production, like YouTube video, you cannot change things. But if you have the original file, you can make changes.
Yeah, but the beauty here is that now you are not sending your file, you are sending link to the data to your other colleagues. So like in Google Docs, you never attach your Google Docs to your email. You just send the link to your colleague, then the other colleague can click the link and can access this data right away. So I hope that this excites you, that you just have an access to 170 gigabyte in size with a simple QR code, right? And you can just do the same thing if you have your own project here. I may go back to this one here. Then let's say have even LiDAR data set here, manage LiDAR data set. If you just click this lock icon here, this is restricted. If you just copy this share URL and send to the others. Let me open up another browser that I'm not logged in. Paste that link. See, I'm not logged in here, but I can still see this 3D point cloud. Same the same way you can share your the rest of the data as well. Okay, so I'm going to go back to restricted. Okay, let me see. I know I'm kind of going very slow, but let me see. Upload the data product, manage project access, simple data visualization in comparison, data sharing and export. And for some reason, you need to download the data. Every data product has a link to download. So you can just click this one so you can download to your local machine. But I mean, this is only when you have to. I'm going to show you how to access this data set without downloading it. Yep.
In your map view, when you're looking at the layers, can you overlay 2 layers instead of putting them side by side and change the transparency?
We are working on the feature right now. We can, but I will show you how you can do this inside QGIS right now.
Yeah, later when we do the programming, you can add as many data layers the same way.
Yeah. Easily. So the part that I'm covering right now is I'm just giving you an introduction of data to science platform. But this platform is designed to be the open, so that any data set you upload over here can be connected to other computing platform. But the one demonstration that I'm going to show you is in the QGIS. And the beauty of QGIS is that now, once you know how to stream this data to QGIS, anything that you do in QGIS can be done using this data set. So I'm going to just give you some quick demonstration of this. Okay. And later, Dr. Wu will give a demonstration about how to access all these data that you see programmatically using Python. Okay. Hey, I'm going to open a QGIS. I should have sent you an email asking you to install QGIS before, but anybody who started from the beginning has a QGIS installed on your laptop? If you do, you can follow through, but if you don't, you can just watch me, and later you can install this QGIS later. Okay, so I just open the QGIS. I can go to the plugin and manage plugin, and if you search for D2S, we published a plugin called D2S Browser. So essentially, this means that now you can stream all the data set that you uploaded to data science can be streamed to QGIS without downloading it. So all you need to do is to search for it, click install plugin. Right now, I'm already installed it, so you don't need to, but you can just do it by just a single click. Another one that I want you to install is there is another plugin called plot boundary. This is also another plugin that we, my group, published where, let's say you have the agriculture field and you'd like to delineate the plot boundary. This, tool provides some easy way to do this. So please, install this in a plot boundary tool as well. So once you have this, now what you can do is click plugin, go to D2S browser and browse D2S data. Now you need to type in the server URL because this is an open source project, so you can, if you want, you can deploy your own instance in your computing platform, because everything is available in a GitHub repository. Even we provide Docker imagery as well on a Docker Hub. So deploying your own instance is going to be pretty straightforward. But instance, for example, we've been working on this in a PS2 instance. So I'm going to type in https ps2.d2s.org. But like I mentioned earlier, in order for you to be able to use these features, you need to generate your own API key. Otherwise, they're going to complain that, hey, I cannot log in because you don't have an API key generated on the server end. Then you just provide your email, and I'm going to just type in my password. So please take any photos or anything. I'm going to go as quick as possible. Click done so that you guys don't know my password. And click login. And what is happening is that now they're going through this login process. Now you see this project has been populated. So now you have an access to all the data that has been uploaded to this data to science. So all you need to do is type in your server URL, email.
The step before this. How did you do this window?
Oh, okay. Okay. So click plugin. After you install D2S browser, this plugin will be available over here. Okay. Click this. Then you just type in the server URL, email, your password, click login. This will populate all the project. And the one that we are working on was my name, Jinha's IPPS and workshop. Once you choose this project, you see all the flight that you added is available. Remember, QGIS is only for raster at this moment. We plan to support the point cloud in the future as well, but at this moment, only supporting raster. So let's say I have a late season and ortho mosaic available. All you need to do is click Add to Selected Map. Now you see this has been added. You never downloaded the data. You are streaming data from data to science to QGIS. Once you do this, this is exactly the same as your local the GeoTIFF file. So you can do different color rendering here. I like to do, for example, 3-2-1 instead of the 1-2-3. Click Apply. You see different rendering here as well. But I'm going to go back to 1-2-3 to have a natural color representation. Let's say I like to have some form of journal statistics to be calculated for my experiment plot here. So let's say this is each of these is a different treatment options, and let's say in order for it to do this, you need to delineate. Hey, this is my one plot, another plot, and etc. So the way how you can do this, like I mentioned earlier, we do have a plot boundary tool. Where is it? Or maybe here. Yeah, plot boundary. I should have put this in a plugin, but if you install plot boundary tool, it's going to be under the vector plot boundary and the general plot boundary. What it'll do is that choose what is our background layer, where do we want to save to. So I'm going to go back to our IPPS in a workshop, and I'm going to say that this is a plot boundary file, and I was playing with it last night, so I know what the setting should be. So I have 8 rows, and you can play with it, and I will show you what I mean by this later. But usually what is in a plot width and the plot height before, and 18 centimeter row spacing and 0.8 meter column spacing, and etc. Okay, and what you need to do is you need to get upper left corner. So I'm going to say that this is my upper left corner. Click generate, and they will generate this in a plot boundary automatically, as you can see. But you see that this is kind of rotated. So this is what I mean by I need to apply -2 degree rotation. But what I'm trying to say is that if you just update this value -2, click generate again, they be aligned accordingly. So probably I need to move this in upper left corner a little bit toward here, generate, and probably a little bit too much. So you can kind of move it around. You got an idea. I'm not going to do super kind of accurate in terms of where you're going to do it. Once you click OK, now you just have this plot boundary located approximately where it is. And if you want to do some micromanagement, you can just go into the edit mode and choose what is the move feature. So move features here. Let's say this one need to be moved. So click here so that you move it around so that they should be here. Let's say if there's anything here, this should be moved over here. This should be moved over here. So you can do some the micro adjustment as needed, something like this. Okay, but keep in mind that before you have to download this data to your local machine. Now you are not downloading any data. You're streaming this in a layer from D2S. Generate this layer. Once you do this, I'm gonna save it and exit out. I'm gonna export this layer as GeoJSON. I'm not a big fan of shapefile because this is in a proprietary format. Shapefile generated multiple file is very hard to manage. So I like to save this as GeoJSON. And in order for you to be able to upload this in a vector layer back to data to science, CRS code should be WJS84. So it should be EPSC code in 4326, essentially latitude and longitude. So I'm gonna save this as this one. I'm gonna come back to this IPPS workshop again, and I'm gonna set a plot boundary GeoJSON. Oh, they already saved, but them saving as the WJS84. Okay. click Save, and click OK. Now this has been added. And what you can do is coming back to this project. So we only look at in a flight. I mean, I don't think I have a time to go to the field data set, but let's say if you upload your the boundary layer that you just created, you can add the new map layer, and you can just drag and drop that the GeoJSON file that you just created, WJSON84. Click upload over here. Then now the actual plot boundary that you just created has been uploaded over there. Now go back to your project. Let me load a late season RGB over here. If you overlay this in a plot boundary, then you're going to see everything is loaded over here. So now you have the plot boundary loaded. What you can do is that there are further data processing that you can do on this server here. Going to workspace. Let's say I'm going to go to this project. The late season, the one that we are working on was RGB here, and as a probably you cannot do this because you are just pure. But anybody who has a manager role or owner role, you can see this toolbox option activated. Now you can say I like to do the calculate the vegetation indices. I like to do EXG. Remember, red was 1, green was 2, blue was band 3. So depending on what kind of sensor that you use, that you need to know what is in a band order. Click Start. Then you're going to see that this is an actual EXG calculation happening on the server side, and this will become available later. And we go to the multispectral toolbox. You can do EXG or an NDVI, and the band near infrared band is in a 5. I know that the red band is in a 1. Click Start. You're going to see that NDVI is calculating over here as well. So I just did the RGB EXG calculation, NDVI. Now what you can do is coming back to this website. Click this one here. Then I'm going to click late season RGB. Now you have, which one did I? Oh, this is the one. We had orthomosaic images, and you calculated the EXG value, calculated, and I see that there's a lot of extreme value over here. So I want to just visualize this value to be 0 and 1. Apply changes, and this is what you're going to see. Then you can just do this in a plot boundary. I like to, this is not a the best example. Let's use multispectral, because the NDVI is the one that probably make more sense. So let's say this is an NDVI. You let it plot boundary, then I like to calculate what is the NDVI journal statistics. Click this in a polygon, all those attribute that is in the boundaries shows up over here, but they give you the journal statistics of NDVI value for your plot, which is mean value is such, maximum is this, mean is here, median is here, what is standard deviation, and how many number of pixels. This can be done by clicking these pixels. And the better way of doing it here is going back to this workspace. I know I'm going very fast. Sorry about this, because I have another example that I want to demonstrate. And going back to multispectral, if you click this toolbox, now you see this journal statistics become available. Now you need to choose that plot boundary that you just calculated. The reason why it shows that download CSV is because I clicked a couple of polygons over there, so they already created this the CSV file ready for it to download. But if you just click Start, what they're going to do is that they're going to go through all the polygons and calculate journal statistics is over NDVI, so that you can have what is a mean, max, average, median, number of pixels, and etc. Yeah.
Does this create a log of all your steps? If you're, I'm assuming if you do this over time, you're going to lose track. So does it have some form of a log or a journal where you can?
It is not. As an admin, I can see what is happening in the back. But probably for that, everything that I'm doing here, you can do exactly the same in Python. So you're going to have a full control of whatever we are doing here as well, which Dr. Wu is going to demonstrate in the second half. Okay. Now coming back here, toolbox, click journal statistics. Now you can download this as a CSV file. Now you can just open this up. And You have everything, what is a minimum value, maximum, mean, median, standard deviation. And right now, that plot boundary I just created only have a row and column number, but let's say you already incorporated this into what is different nitrogen application rate, what is in a different variety. All those information is available as a row, and you can use this that one to create whatever figure that you just want to do. So everything that we are demonstrating here can be actually run on this platform. We are keep expanding these features to provide more features. But let's say, like the gentleman in the back asked a question, what if I want to do additional stuff? That's where this QGIS is going to come into play. Python is going to come into play. I also did another workshop with the Field Image R group. I'm not sure. How many of you heard about Field Image R? Nobody heard of it before? This is R packages to do phenotyping analysis. And this Field Image R is kind of getting popular if you're an R programmer. I'm a Python programmer. That's the reason why we to provide Python packages. But we do have an option to access on all this data using R, using Field Image R. We did the workshop recordings, and that one is also available in our channel. So if you're interested, you can go and watch it. Essentially, Field Image R has been integrated into QGIS. You have D2S, the browser plugin QGIS. You stream your data set from D2S to QGIS. Then you just use the Field Image R implementation inside the QGIS to do whenever the phenotype analysis you want to do. Let me just go back to the other the project, because I know I've been talking nonstop. I'm pouring lots of information to you guys, but we have a lot of things that we want you to know, but with the limited time. So yeah.
When you create the plot, you can add a column that every plot has a name and something to identify it. And so when you export data, you have the name of the plot.
Yeah. So I'm about to show another example where all those things are already popular. Because I'm just doing those plot boundary delineation on the fly. Yes. I'm not adding other information, but I have another example where I can show you exactly what you're talking about. So give me a second.
Easier for statistics
yeah.
or
yeah.
Excel file.
Yeah. Yeah. But the point I'm trying to make here is that there's going to be a lot of things that we can do. We just building this platform as an open architecture so that you can plug this into whatever platform you want to do. So let me just show you two other examples that we are going to use in the second half. First one is a workshop example. If you click this one, I'd like to acknowledge the data source. This is one of my colleagues, Dr. Daniel Quinn from Purdue. He's the corn specialist in Indiana, and he's been going to a lot of cornfields in Indiana, doing a lot of UV flight, and I kind of convinced him to share this data set with all those workshop participants. So you guys already have access to this project. So I have an acknowledgement here. This is provided by Dr. Quinn's research group, and this is collected by one of his graduate students, and etc. So coming back here. If you just manage the data, we just have one auto-mosaic images. If you click view, then we are going to go to this farmers in a cornfield over here. This is the field that we are doing different nitrogen, the variable nitrogen application. And we also have this experiment design overlaid over here. And once you click each polygon now, you're going to see a lot more than row and column. What is a repetition number? What is in a plot ID? What is the size? What is the application rate, which is 60? And I think this is in a variety trial. We can type in, hey, this is in a variety A, variety B. So when after you create that plot boundary, if you have a little field layout, you can merge that table with the plot boundary, then upload that file to this D2S. Then you have all this information already available. Coming back to here, right now we only have auto-mosaic images, but if you'd like to click this one here, it's going to say select the single band data product to visual statistics, because you cannot do journal statistics on RGB. You need to have a single band layer so that you can calculate what is the mean value of NDVI, EXD, and etc. So what we can do here is we can go to this workshop project here, then go to manage data. Let's go to toolbox. Let's generate the NDVI. Like I mentioned earlier, this is band 5 is the near infrared band. 1 is red band. Oh, the other way. 1 and 5, right? Red band is 1, near infrared is 5. Click start. And again, this is a lot larger file than the other one. This is about 4 GB in size. So it will soon start to show up doing the data processing in the back. Hopefully, it'll soon. Okay. Come on. But to give you an idea, let me show you the actual NRCS. This is another slide. We can just do the NDVI generation here. I'm just kind of showing you. I'm going to just make a shortcut. You can just do NDVI, click this toolbox, do zonal statistics, click that specific boundary that you got. I already processed this CSV data. Click download CSV. Then if you open up this in Excel, now you have all those zonal statistics for NDVI. You have treatment option over here. Now you can just create a scatter plot depending on X amount of nitrogen application. What is NDVI? You can just do this calculation with a single couple of clicks. Imagine that you have the multiple flight throughout the season. You can just do this manually by clicking through this. And the even better way of doing it is that Dr. Wu is going to demonstrate. You can write a script to just automate this process. Hey, just grab all the flight throughout the season, doing NDVI calculation using this the boundary, doing zonal statistics, create a figure. And I think Dr. Wu has some example to demonstrate these features. Even better thing is that now you can pull all the satellite data set from GMAP, where all those data you didn't fly, you can pull the satellite images like a Sentinel Lancet. You can just do the NDVI calculation throughout the whole season as well. So there's going to be additional kind of the features that we're going to be looking at. Let me see if I just go back and see this NDVI has been calculated. Oh, this is not the one. Sorry. Workshop here. Yep. This NDVI has been calculated, generated before. So if you go to zonal statistics over here, I never calculated this zonal statistics before. Click start, and there are actually a crunching number in the back. And since everything is running on the server side, this should run pretty quickly. Probably if I just click this zonal statistics, now this CSV is ready to download. You can just go from there. Another project that you're going to be encounter later is citrus orchard example. We have 2 flights, one in June and one in December. And I'm not going to talk too much about it, but essentially we have the orthomosaic images, DSM. We also generate the CHM, which is essentially the canopy height model, so that we just eliminate all those topography in effect. And using this orthomosaic images. And we also have this, using plot boundary tool that I demonstrated earlier, what is width and height, just by clicking upper left corner, just click a button, they just generate this rectangular box. And Dr. Wu is going to demonstrate how we can use this kind of information to individual tree segmentation inside the Python. So hopefully, Dr. Wu, I didn't steal too much of your thunder. That's coming, but this is some of the example data set that you're going to play with. You can see CHM data set over here, DSM. You have earlier flight orthomosaics, and as well. So I know. Let me just go through my note to make sure I didn't miss anything. Yeah, I think I covered everything that I wanted to. And have any question?
You mentioned that this is open source. Is there any way that you can actually contribute? Do you have the GitHub repository?
Yes. So GitHub repository is github.com, GDSL. Just show you data to science. So this is public repo. Just click this. What is going on? So go to data to science. I think my code.
Maybe you have using downtime.
No, yeah, this is the GitHub repo. You can submit issues over here. If you have any suggestion, you can submit the pull request. Yeah. And another thing that I mentioned is that the PS2 platform is open to public. I'm just keep saying this. Just you can upload as much data as you want. There's no limit at this moment. I cannot guarantee that this will last forever, but at least we have plenty of storage space. So please use it. Please spread the word. And I'm only showing the tip of the iceberg right now. Real power is going to be when this is combined with Python packages, where Dr. Wu is going to demonstrate in the second half. But please use it. Download your data. Like I mentioned, this is your data. Even I, as an admin, I cannot see your data set unless you give me an access to your project. Any questions? I hope you enjoyed it. We are not done yet. What I'm going to do is we're going to take a quick 20-minute break, and we will convene at 11 o'clock. Okay. Thank you.